Morning students, in the last video already you have discussed the self-induction. Here we have to find out the mutual induction. Whenever the term mutual comes here, that means that is two coil will be decided here, and in one coil the current will be flowing and the change in magnetic flux will be linking to the second coil, no doubtly. So whatever the induced current which will be produced in the second, or that is the secondary coil, this phenomenon depends upon the pairing of the coupling of the two coils, and whatever the induced current which will be produced in the secondary coil, this phenomenon is termed as the mutual induction. So it is the phenomenon of production of induced EMF in one coil due to the change in current flowing in the neighboring coil. That is the mutual induction. In the neighboring coil, this is the primary coil. If the change in current flows through the primary coil, I am talking about always the change in current, because whenever the change in current we can obtain it by switching off and on. If you make switch off and on, then the increase in current will be flowing through the primary. If it is made off, then decrease in current will be flowing through the primary. Means the current will flow down, will decrease. And in that situation, what will happen? That change in magnetic flux, magnetic field will be created around the primary coil, and the magnetic flux will be linked to the secondary coil, and the change in magnetic flux will be linked to the secondary coil, and hence the induced current will be produced in it. This property or this phenomenon is called the mutual induction. That is mutual induction. So it is clear the change in flux linked to the secondary coil, the change in flux linked to the secondary coil is directly proportional to the current flowing in the primary coil. So phi is directly proportional to I. If the current flowing will be more, flux linked will be more. If the current flowing will be changing, then the flux linking also will be changing, and hence the induced current will be produced in the secondary coil. So phi equal to, that is Mi, that is proportionality constant is coming. That M is called the mutual inductance or coefficient of mutual induction. So from here, from the definition you are getting phi equal to Mi, if I equal to 1 unit, that phi becomes M. That coefficient of mutual induction or the mutual inductance of two coils, because whenever you talk about the mutual induction, then we are taking the mutual inductance of one coil with respect to the another one. The mutual inductance of two coil is defined as the flux linked to the secondary coil whenever the unit current flows in the primary coil. So in this manner we can find out, we can define it as the mutual inductance of two coils. In the other way also, if that is from the Faraday's law, if you use Faraday's law, E equal to minus d phi by dt, that is equal to minus dy dt of phi, that is equal to Mi, a minus M di upon dt. And here what you are getting it, and here you are getting, that is magnitude of E, that must be equal to M into di upon dt. So if di upon dt equal to di upon dt is equal to 1 unit, then the EMF which will be induced in the secondary coil, that is equal to coefficient of mutual induction or mutual inductance. The mutual inductance between two coil is defined as the induced EMF produced in the secondary coil whenever the unit rate of change of current flowing in the primary coil. The unit rate of change of current flowing in the primary coil. If the change in current flowing in the primary current is by 1 unit, then induced EMF, the amount of EMF which will be produced in the second coil, that is equivalent to that of the mutual induction, or coefficient of mutual induction or mutual inductance. So in this manner we can calculate the mutual inductance of the unit is same, Henry is the unit, and that 1 Henry equal to, here also you can define as 1 Henry equal to 1 Weber per 1 ampere. And we have to find it now, that what is the mutual inductance of two long coaxial solenoid. Mutual inductance of two long coaxial solenoid. Mutual inductance of two long coaxial solenoids. Two long coaxial solenoids. So we have to decide it, the two long coaxial solenoid. One solenoid is here, one solenoid you are deciding it is here, and another solenoid is coaxially, and both the solenoids are coupled. This is another solenoid. And in the first solenoid, that is, you can tell it as the S1. This is the S1 and this solenoid is the S2. And in S1, the current whichever is flowing is I1. So when the current, what will be the mutual inductance of these two coaxial solenoid, because axis is same, it is having the common axis. So we can tell it as the I1 is the current flowing through the solenoid, I1 equal to current flowing in solenoid S1, and N1 is the number of turns of S1, and N2 is the number of turns of S2 of S2. So what will be the, whenever the current is flowing through the S1 solenoid, the magnetic field will be developed, the magnetic induction due to solenoid S1 carries current I1. The magnetic field which will develop due to the first solenoid whenever the current is passing through the S1. So this will be equal to, we can tell it as the, that is B equal to mu naught N1 I1, because you know that is the magnetic field due to the current carrying solenoid is mu naught Ni. Mu naught is the permeability of free space, N is the number of turns per unit length, and I1 is the current flowing through the first solenoid. Clear? So what is the magnetic flux? The magnetic flux linked to solenoid S2. What is the magnetic flux linked to the solenoid 2? So we can talk about the phi 2, or the flux, you directly do it, the flux phi, that is equal to B into A, flux linked B into A, and if it is having the number of turns is N2, the number of turns will be the N2, that is the flux linked to the 2, if you can use the phi 2. Phi 2 equal to B A N2, and this will be equal to, what is B? B equal to mu naught N1 I1 A capital N1. So this is equal to, if you write it in this manner, mu naught, if this N1 equal to, sorry, this is the N2, A N2. If N1 is equal to N1 upon L I1 A N2, or simply you can write it as the mu naught N1 N2 I1 A upon L. This is the flux linked to the second solenoid S2. So you know that from the definition is that flux linked to the solenoid 2 is directly proportional to, that is equal to, that is mutual M into I1. The flux linked to the second coil is directly proportional to the current flowing in the first coil. That is second coil equal to phi 2 equal to M into I1. That is the mutual induction of, that is, you can tell it as the 2 with respect to 1. Mutual induction of 2 with respect to 1, M1 to I1. We can write in this manner. Phi, this is equal to equation number 1. You take it to the equation number 1. This is the equation number 2. So you compare both the equations, you are finding M12 I1, that is equal to mu naught N1 N2 I1 A upon L. So that I1 is getting cancelled, and you are finding M12 equal to mu naught N1 N2 A upon L. That is the mutual induction, by coefficient of mutual induction of coil 2 with respect to the coil 1. Similarly, if the current is flowing in the secondary coil S2, and we can find the linking of the flux to the S1, and induced current will be produced in the S1, and if you find that one also, you can get it the mutual inductance of 2 with respect to 1 with respect to 2, and 2 with respect to 1, that is also mu naught N1 N2 A upon L. And in whole you can get it as the mutual inductance, because of it is depending upon the coupling of the coils. So here in both the cases we are finding mutual inductance, that M12 equal to, and this is the final one, is M12 equal to M12 that is equal to M21, that is equal to mu naught N1 N2 A upon L. That is the mutual inductance between two coils. So that is the mutual inductance of two coils, and that mutual inductance that depends upon the coupling of the two coils and the nature of the material inserted in between the two solenoids. Suppose if that a substance of relative permeability mu r is introduced in between the coil, in between the solenoid. If mu r is the relative permeability is introduced in between the solenoid, then you can get it as the M12 equal to M21, that is equal to, in place of mu naught you can write the mu r mu naught N1 N2 A upon L, because the relative permeability, we must be knowing relative permeability equal to permeability of the medium upon permeability of free space. So here you are getting the mu r mu naught N1 N2 A upon L. This is all about the mutual inductance of two different coils. Thank you.